All right, so as I said, there's not really a whole lot for me to cover with this. We're gonna just do some problems. So let me just go ahead and write out the first one. What U substitution allows you to do, and hold on, let me write this. I can't write and talk at the same time here. What U substitution allows you to do is chain rule in reverse. So we're doing antiderivatives. So it's a derivative backwards. It allows you to do a chain rule in reverse. So far, all the functions that I've given you that we've done antiderivatives of, I've just said, hey guys, think of a function that if you did the derivative, you could get this. Like this would be your answer. We're just doing it backwards. A chain rule, it's a little bit bulkier. There's a little bit more to it. So what U substitution allows you to do is a chain rule in reverse. I don't know who picked U as the letter that you're going to substitute, but that's like what it's literally called. So we're going to do U substitution. So you have to decide what you're going to let U equal. And as you do these, it'll become more like instinctual and second nature. But here's the thing, if you pick wrong, the problem won't work. Like all the puzzle pieces are going to have to fit and match exactly. So you almost can't mess these up. Like if you pick the wrong thing, it's just not going to work. And you'll be like, oh, whoops, guess I need to pick something else. But you would want to pick whatever is the guts of the problem. You know how when you do a chain rule, it's like there's that inside stuff. You would want to let U equal the inside stuff or the thing with the highest power. So when we look at this, U is going to have to either be the stuff in the first parentheses or the second parentheses. I want to pick the stuff with the highest power. So I'm going to let U equal this. So the x to the 6 plus 2x squared. And then we're going to do the derivative of that with respect to x. So remember how we did dy dx, that I said like the letters could really be anything? This is going to be du dx. And you're going to end up skipping this step. I'm going to show you in a second. This is the only question I'm going to write this step out on because you're going to end up just skipping it for all the other ones. But we're going to do the derivative of this. So that would be 6x to the 5th plus 4x. So that is the derivative of what we just have there. And then what you're going to do is multiply the dx over. So you're going to have du equals all of this times dx. So you're not just skipping that step and jumping straight here. It's du equals, then you do the derivative and put dx. Now here is where you go hunting for that in the problem. This has to match or it literally won't work. And I'm not going to give you an undoable problem. So you have to be able to find this in the question here. Now it almost matches. We have 6x to the 5th plus 4x. But this says 3x to the 5th plus 2x. So what do I need to do to this to make it match what's here? That's my question to you. Hey guys, how do I need to fix that? Good, a half, divide by 2, a half, perfect. You guys rock. All right, so we're gonna do a half of du. And when you do half of this, it'll be 3x to the 5th plus 2x dx. It will literally match. And this is the part that I highlight, or if you wanna just underline it, it will match exactly. That matches and the dx matches. And it will literally work every time. I can't give you an undoable problem, so it will be there. These problems are great because they're set up to work. So it's gonna match. So in place of what we highlighted, we're gonna put 1/2 du. It's U substitution. So we're substituting in for this highlighted stuff, 1/2 du. So 1/2 is going to go out front. du is going to go at the end. This is the most important thing I'm going to say. Whatever you didn't highlight is still there. Whatever you didn't highlight is still there, which in this problem is this stuff, which is what we let equal U. Yes, that's all that's left. The whole point of U substitution is to take something that looks really complicated and make it look a whole lot simpler. That's the point. In fact, what people often end up skipping is doing the antiderivative. They'll forget to actually take an antiderivative because it ends up looking so simple that there's like nothing left there. But don't forget to do the antiderivative of this. We've got this 1/2 out front. Antiderivative of U is 1/2 U squared. And then we'll have plus c at the end. So don't forget to actually do the calculus. Do you remember we were doing optimization problems and I was like, this is a whole bunch of algebra and there's only one step that's calculus where you do the derivative? This is basically, well, you do a derivative here, but it's basically a lot of algebra with the substituting. This is the most important step to get from there to there, is actually doing the antiderivative. Okay, I think I hammered that hard enough, right? And then at the end, you're going to take this and plug it back in for u. So a half times a half is a fourth, and then u squared, and u is this stuff. It sounds like I don't know how to talk when I teach this. U is all of that, and then plus c, and this is your answer. Now, for the sake of time, because everything just takes longer teaching virtually, so I'm not going to go through this, but if you do the derivative of this, you will get this. I promise. Work that out. I swear it'll work. We just did an antiderivative. That is literally the process, and we're gonna just try a whole bunch more problems. I'm sorry, I don't know what part cut out. Hold on a second. All right, so to get from here to here, we did the antiderivative. For u, that's 1/2 u squared. And then at the end, you just plug back in for u. So I put this statement back in for u. So a half times a half was a fourth, and then it's all that stuff squared plus c. And if you do the derivative of this, you're going to get what's here. And I'm not going to work through that just for the sake of time here, but if you did the derivative of this, you would get what we started with. All right, so let's try another one. Right, so we have to decide what to let u equal. But again, if you pick the wrong thing, it's just not going to work. And you'll be like, oh, guess I should pick something else. But you want it to be whatever is the guts of the problem, like what's the inside stuff or whatever's the highest power. And the insides of the problem, it's e to the stuff. We're going to let u equal all of that. So u is going to equal that. And then we're going to do the derivative of that. So du equals, and this derivative would be 4x plus 4 dx. And like I said, you're going to end up skipping this step because it's just, you end up writing the same thing twice. So you may as well just skip straight to here. Du equals the derivative and then dx. And then you have to find that in the problem somewhere. And I swear it's going to match. These problems are set up to work. So look for this in the problem somewhere. What are we going to have to do to adjust it to make it match perfectly? Divide by 4. Perfect. So 1/4, guys are awesome, equals x plus 1 dx. And then if you want to, you can highlight it. It's going to match exactly the x plus 1 and the dx. So in place of what you highlighted, you're going to substitute 1/4 du. So 1/4 goes at the end, or I'm sorry, 1/4 goes out front, du goes at the end. Whatever you didn't highlight is still there, which is e to all this stuff. And so it's e to the u. And again, the whole point, you're going to be like, what happened to the problem? It's all gone. The whole point is to make something complicated look really simple. Now, the next step's the most important step, which is where you do the antiderivative. It's going to look like we didn't do anything, but that's because e to the u, the antiderivative is e to the u plus c. And then at the end, you're just going to put this back in for u. So it is 1/4 e to the power, all of that, plus c. We'll do one more together and then I'll let you guys try one. So go ahead and take a second and write that one down. But do you see what I was saying is like, this is very process driven. So like once you get used to the process, you can just start churning out these questions. become a little correct answer machine. All right, so we want to let u equal the inside stuff. So that's going to be what's inside of the square root here. So we're going to let u equal x cubed plus 1. And I'm sorry, I just saw a question in the chat. Sorry, let me go back. Du cancel out. The du doesn't cancel out. That's taking the place of the dx. So when you do the antiderivative, you no longer write the integral symbol or the du. Remember, when you take the antiderivative, you no longer write those symbols. You have a plus c, or if there are boundaries, which I'm going to do an example that has boundaries here in a few minutes, you would have like the such that bar. But remember, when you do an antiderivative, you no longer write those symbols. It doesn't cancel out, it's just that you've done that step. It's like this. Give me a perfect square, guys. Tell me any perfect square. 16. All right, when you do square root of 16, oh, I'll do all of those. When you do square root of 16, you get 4, not this. When you do square root of 36, you get 6, not this. It's like once you do the process, you no longer write the symbol. Like this would just be 9 and this would just be 5. Once you do the square rooting, you no longer write the square root. So once you do the antiderivative, you no longer write the symbols for the antiderivative. So they don't, I think cancel out isn't the word I would go with. It's just that you've done that process. So you no longer write it. Okay, so for this one, we're going to let u equal this stuff. And so that derivative is going to be 3x squared dx. And then you go and hunt for that in the problem. It has to show up. Now you may need to adjust, and you can only adjust like a coefficient. You can't adjust a variable, like you can never multiply by an x or something. But what are we going to need to do to this one to make it match what's over there? Yep, good, perfect, times 4. So 4 du equals 12x squared dx. And then if you want to highlight, you can. I think it helps. The 12x squared and the dx, in their place, we're going to substitute 4 du. So 4 goes out front, du goes at the end. Whatever you didn't highlight is still there. And u is all this stuff. So we have square root of u. I'm going to write that as u to the 1/2. That is square root of u. So u to the 1/2. And the next step is the most important step. We're going to do the antiderivative. So you add 1 to the power. That would be u to the 3/2. And so I'm going to need a 2/3 out front. So that's the most important step, is doing the antiderivative. And then at the end, you're going to put this back in for u. And also, I'm going to multiply these together. 4 times 2 would be 8. So we're going to have 8/3. And then this would be square root of u cubed. And u is this statement right here. So x cubed plus 1. And then plus c. All right, so let me give you guys one to try. I'll just pause the recording, give you like a couple minutes. I just want you to try it, and then I will go over it for you. All right, so I hope you got a chance to just give that a try. Let me go over this one for you. So we're going to let u equal the inside stuff. So this 3x squared plus 6x. And then we're going to do that derivative. So that derivative would be 6x plus 6 dx. And then we're looking for that in the problem somewhere, which it is right here. I just need to divide by 6. So it's going to be 1/6 du equals x plus 1 dx. So the x plus 1 and the dx are getting substituted out. In their place, we're putting 1/6 du. So 1/6 goes out front, du is at the end, and whatever we didn't highlight is still there, and it is this stuff to the fourth, so u to the fourth. And so the next step is where we're going to do the antiderivative. So this antiderivative would be 1/5 u to the fifth, then plus c. And then last step, well, I'm going to multiply these fractions together. That'll be 1/30th. You just have to plug this stuff back in for u. So it'll be all of that to the fifth. So I'm just going to put this 3x squared plus 6x back in there. All right, so I hope that went well. I just wanted to give you time to like try one. I'm going to do a few that turn out a little bit differently. I know like she's going to change it on us. It's not going to be too much different. Just show you some other things that can happen, and then we'll do some that have some boundaries on them. So for this one, it's kind of like, well, what am I going to let u equal? Again, you want to let u be the inside stuff, like the guts of the problem. We're trying to do a chain rule in reverse. So choosing between these two, which do you want to let u equal? You want to let u be the x minus 1, since that's what's being taken to the fifth. And so when we do that derivative, the derivative of x is just 1. You could write a 1 there if you want. It's just going to be 1 dx. So the only thing that gets substituted out here is the dx, which is kind of a problem because when you go to substitute, I'm going to change the dx to a du. This part right here would be u to the fifth, but then I've got this x plus 3. Now I can't put x plus 3 there because you can't mix and match the x's and the u's. When you do a u substitution, you have to change it all to be u's. If you ever end up with a step where you have some x's and some u's, then you have done goofed. Like you have to go back and find where the mistake was because you can't have them mixed and matched in there. So what I'm going to do over here is solve this for x. I'm just going to add over the 1. So u plus 1 is equal to x. I just added this 1 to the other side. And in place of this x right here, I can put u plus 1. So it's just another substitution. In place of x here, I'm going to put u plus 1. So this would be u plus 1 plus 3. So it's going to be u plus 4. And so now it's all u's. I don't have any x's anymore. And before I do this antiderivative, I'm going to distribute through the parentheses. It's just simplifying down before you do the antiderivative. So notice I'm keeping these symbols. This is like piggybacking off of that conversation we just had a little bit ago. I'm not doing the antiderivative yet, so I'm going to keep those. So if I distribute through here, that's going to be u to the 6th plus 4u to the 5th. And then I'm going to do the antiderivative. So this would be 1/7 u to the 7th plus, now you'd want this to be 1/6 u to the 6th, but there's a 4 there. So it would be 4/6 u to the 6th plus c. And then last step, we're going to plug x minus 1 back in for u. So this is 1/7 times x minus 1 to the 7th plus, and I'll reduce that. That'll be 2/3 x minus 1 to the 6th plus c. So again, you can't mix and match the x's and the u's. So I just took this statement over here, solved it for x, and then we were able to plug this in for x so that it was all a u statement. That answer looks really weird, but I kind of like it. All right, and then I just want to do a couple that have boundaries on them. So there's 2 ways that you can approach these. I'm going to show you both. One of them is less work, so that's probably the one you're going to end up doing. but I'll show you both. So there's two ways you can kind of go about this if there are boundaries. So we're not going to have a plus c. This is a definite integral. We're going to do the antiderivative and then upper boundary minus lower boundary. All right, so for this one, we're going to let u equal this inside stuff. So 2x squared plus 1. And so that derivative is 4x dx, which is actually great. We don't even have to adjust it at all because it just already matches exactly. That actually tends to throw people off. They're like, wait, there's not an adjustment? No, it just already matched. So you're not going to have, like a coefficient out front. So it's nice. So in place of what I highlighted, I'm going to put du. And then whatever I didn't highlight is still there. So it's this stuff squared. So that is u squared. And so what I need to do is adjust the boundaries. These boundaries are x values. And like I said, you can't mix and match x's and u's. So you have to change these x values to u values. It's really easy to do. You just need to not forget. All you have to do is plug them in for x over here and see what you get for u. It's exactly like when you plug into a function, like you plug in for x and you get y, like you're going to plug in for x and get u. So if we plug in 0 for x right here, that's going to give us 1. And if we plug in 1, that's going to give us 3. So you have to adjust the boundaries. And again, like I said, it's really easy to do. You just need to not forget. So then we're going to do the antiderivative. It is 1/3 u cubed such that 1 to 3. And now since we've adjusted the boundaries, I don't need to plug this back in. You get to skip that step, which like I said, that's less work. So that's kind of nice. You don't have to plug this back in. All you have to do is upper boundary minus lower boundary. So we're going to plug in the 3, plug in the 1, see what we get. So 3 cubed would be 27 thirds. So that's 27 thirds. That's our upper boundary. Minus lower boundary. If you plug in 1, you're going to get 1/3. And so your final answer to the whole thing is 26 thirds. So let me show you the alternate way to do it. This is the way I sort of recommend. And on the AP exam, sometimes they will force you to change the boundaries. Like they'll make it a multiple choice question and they'll say, what is the substitution? And like, this will be your answer. So like you have to be able to change the boundaries. But I will show you the other way if you want to do it the other way. So I'm going to pick up on this step because the beginning part would all be the same. So you would have integral u squared du. Instead of changing the boundaries, if you don't want to do that, what you can do is just sort of ignore them for a second, like just leave them off, like leave it blank. Do the antiderivative. Again, that would be the same. And then you would, if you don't want to change the boundaries, you would have to plug this back in. So this would be 1/3 2x squared plus 1 cubed. And then when you do such that, you can leave the boundaries what they were in the original problem, like leave it 0 to 1. So it's an alternate way you can get through it, and you'll end up with the same answer. So you don't have to change the boundaries, but you do have to plug this back in at the end. Because again, these are x values, not u values. You will get the same thing. If you plug in 1, this is our upper boundary, you'll have 3 cubed, so 27 thirds minus, and then if you plug in 0, you're going to get 1/3. So like it's going to come out the same, just an alternate method. But I am going to fit the last question on here because I don't want to have to get out a brand new piece of paper for one last question. I just want to do another one that has boundaries so that you can see that again. So let's just try one more here. All right, so for this one, we're going to let u equal the 1 plus 2x. That's really the only thing it could be for this problem. You kind of don't have a choice there. Derivative of that is 2 dx, but I need for it to be an 8. So I am going to multiply by 4. So 4 du equals 8 dx. And that is what we are going to substitute in for. It's so funny when I teach this in person, when we do this lesson, you can hear everybody like capping and uncapping their highlighter as we go through it. So in place of what we highlighted, we're going to put 4 du. So 4 goes out front, du goes at the end. Whatever we didn't highlight is still there. So u cubed. And then you just have to change the boundaries, which is easy to do. You just plug these numbers in for x. So plug in for x, you get u. So if you plug in 2, you're going to get 5. And if you plug in 4, 4 times 2 is 8, plus 1 is 9. And since you've changed those, you don't have to plug back in this statement at the end. It's less work. So antiderivative would be 1/4 u to the 4th, such that, and then from 5 to 9. And what's nice here is the 4 and the 1/4 are going to cancel. So those are gone. And just upper boundary minus lower boundary. So that would be 9 to the 4th, which I don't know what that is off the top of my head, but 9 to the 4th minus 5 to the 4th. And I'm going to just leave it like that. So whatever that is. Now, again, let me just show you the other way. But again, you do need to learn this way, because on the AP exam, they will give you this as the question and ask you, what does the substitution look like? And then this would be the answer. So you have to be able to learn how to do it this way. But so it would start out the same way. You would end up on this step. You would have 4 integral u cubed du. If you don't want to change the boundaries, just leave it blank for a second. Just, don't forget to bring them back, but leave that off. You would do this antiderivative, which again is the same as what we just did. The 4 and the 1/4 would cancel. But if you don't want to change the boundaries, you do have to put this back in at the end. So this would be 1 plus 2x to the 4th, such that, and you would leave the boundaries the same as they were. You don't have to adjust them. So it would be from 2 to 4. But it's going to come out the same. If you plug in 4, you're going to get 9 to the 4th minus, and then if you plug in 2, you're going to get 5 to the 4th. So whatever is your preference there. But again, you do need to be able to change the boundaries if necessary, because they do put that in multiple choice questions.